Hi guys, in this video I will show you why the strategy to solve the problem 1792 on lead code is to add just one extra student to the class C, which have the highest increase in ratio. This proof is not found in others videos or the solution. Maybe you have seen other solutions or videos and you are not totally convinced why we have to add one. Maybe you have they work with only examples, or the proof is not understandable by you. Let's denote delta ck, the increase in the pass ratio of the class C when k extra students are added to that class. Let's take just a quick example. If we have initially this class, these classes, class 0, they can pass the exam. Let's call PC the number of students they can pass the exam. 1 for the class 0, 3 for the class 1, and 2 for the class 2. And the total students in each class for the class 0, 2, for 1 is 5, for the class 2 is 2. So the ratio here, 1 for the class 0, 1 over 2 is 0.5. For the class 1, 3 over 5 is 0.6. And for the class 2, 2 over 2 is 1. Let's say that we will add k is equal to 2 for each class. So this student will pass the exam also. We have to add it to PC. So the PC of the first class is the 3, 1 plus 2 is 3. For the class 1, 3 plus 2 is 5. For the class 2, 2 plus 2 is 4. And also the total student in each class will increase by 2, 4 here, 7 here, and 4 here. So the new ratios are 0.75 for the class 0, 0.7143 for the class 1, and 1 for the class 2. So delta C2 for the class 0 is the new ratio minus the old ratio. The increase for the ratio here, delta 02, the class C02 is 0.25. Same for the class 1 here, new ratio minus the old one, 0.11. And for the last class here, 1 minus 1 is 0. The new ratio is 1, the old ratio is 1, so 1 minus 1, the increase is 0. This is what we call delta C2. So in general, delta CK is the increase in the pass ratio of the class C when k extra students are added. So we have to answer the question why the best strategy is to add one extra student to the class C, which have the highest delta C1. We add just 1, k is equal to 1. Why? So delta CK is equal to PC plus K over TC plus K. So we have added K student. This brilliant student will pass the exam. So we will be added to the student that have passed the exam in the class. So PC plus K over the total. Also we add K, TC plus K, minus the old ratio, which is PC over TC. So if we compute the derivative of delta CK by respect of K, we'll have this formula, because here is this function here is fk over gk minus c. This is fk, this is gk, this is a constant c. So as you know, the derivative is, we can compute the derivative of this function like this. It's shown as shown here. So we have this formula here, tc minus pc over tc plus k squared. And we know that, of course, the total of the number of total number of students are greater than the student who will pass who passed the exam. So here in the range 1m, where m is the number of extra students, is negative. So we can conclude that delta ck is monotonically decreasing from 1 to m. So there is no need to choose ek greater k greater than 1 here, because if we choose a great k, the increase of the ratio will decrease. So as you see here, delta k increase, the increase pass ratio of the class C, delta ck, decreases as k increases. So that's why we have to choose one, the minimum k that we can add. This k here, when adding one, that is the maximum delta ck that we can have. So always we have to take delta c1 and check which class have the highest delta c1 and compute its ratio and update the ratio by this delta c1. I hope this proof show you why we need to add just one extra student to the class C, which have the highest increase in ratio. Thank you for watching.